Okay, in this video we're going to look at what it means to graph linear inequalities. So before we begin, we want to note the following bits of information. Okay, back when we had number lines and just number lines, when we just had less than or greater than, this meant we had an open circle. Okay, for example, x is less than 2 means we had an open circle at 2 and we shade it to the left. Less than or equal to or greater than or equal to meant we had a closed circle. So if it was x is less than or equal to 2, that means we had a closed-in circle shaded to the left. Okay, we have the same type of distinction whenever we're graphing linear inequalities on a graph, on our x and y axis. So for graphs, if we just have less than or greater than, this means we have a dashed line. Okay, it means that line's not included in our answer. So for example, if we have y is less than x, we have a dashed boundary line. Okay, and then we have the region shaded underneath. If we have less than or equal to or greater than or equal to, that means this boundary line is included in our solution, just like our boundary point is included in our solution up here, and we represent that by using a solid line, okay, or a regular line. So we have a solid line here, so this is y is less than or equal to x. Okay, so we have the same type of difference with our graphs as we did with our number lines. Okay, we have to pay attention to our inequalities and know, are we going to have a dashed line or a solid line? Okay, so let's look at our first example. Okay, so we want to graph the inequality y is less than or equal to 2x plus 1. Now what this means is we want to find all the points, because we have two variables, so our solutions are all the coordinates where our y value is going to be less than or equal to 2 times the x value plus 1. Now, just like when we had solving basic inequalities, the first thing we did was find our boundary point. Well, we do the same thing with graphing our lines. You find our boundary line. That is, we want to know when will y equal 2x plus 1. So we just graph the line y equals 2x plus 1. Our y-intercept is 1. Then what's our slope? 2. So we go up 2 over 1, up 2 over 1. And we just graph this line. Now we put the points in to graph this line. The thing that's different here is we need to ask ourselves, well, is this going to be solid or dashed? So we look at our inequality. So this is or equals to, so we look back up here, or equals to means we had our solid line. So which means we draw a solid line through these points. Now again, this is called our boundary line. This is where y equals 2x plus 1. So now we want to figure out which side of the graph, or which side of this line, is y less than 2x plus 1. So that's what we want. When is y less than 2x plus 1? Okay, this says less than or equal to, but again, this line is when it equals to it. So we want to find which side of this graph, okay, above it or below, or sorry, which side of this line, above it or below it, will y be less than 2x plus 1. And we did the same type of thinking when we had our boundary point on our number line. We want to know which side of that boundary point are the values going to give us less or greater, because that boundary point is when it's switched. The same thing's here. On one side of the line, y is less than 2x plus 1, and on the other side of the line, y is greater than 2x plus 1. So we want to find which region is y less than 2x plus 1. So here, we test points. Now you're going to learn very quickly a shortcut in how to answer this question right away, but for us to get in the same process and connect to what we did before our prior learning, we're going to test the point. So you're not just going to test a random point. Okay, you want to make an educated guess. If you were going to make a guess on which side of the line you would shade, on which side of the line is y going to be less than 2x plus 1, you want to think. And again, once you do a lot of practice, you're going to get better at thinking, you're going to make better first guesses. So let's start and let's say, well, maybe we're on this side of the line. Okay, maybe this point's a solution. So we pick a point. This is the point 3, 2. Okay, our x equals 3, the x coordinate's 3, the y coordinate's 2. So we want to know, is 3, 2 a solution? That means if x equals 3, if we do 2x plus 1, is our y value, which is 2, going to be less than that? So really this is done mentally. Okay, so we do, if x equals 3, what's 2x plus 1? So we do 2 times 3 plus 1, and we get 7. So again, I'll just write this down so we keep track of what we're doing, but as you get good at this, this is what's done mentally. We do 2 times 3 plus 1, and this gave us 7. So this equals 7. Our y coordinate is 2, so we're basically asking ourselves, is 2 less than 7? Okay, this was our y. Y is 2. Is this less than 2x plus 1? If x equals 3. So we do 2 times 3 plus 1 is 7. Is 2 less than 7? Yes, of course. Well, what does that mean? Well, that means this 0.32 is a solution. So again, we don't ever write this, but this is what it means. 3, 2 is a solution. Well, that means every single point on this side of the line, again, there's two sides. We ignore the axes here. We have this side of the line and this side of the line. Well, every single point on this side of the line is a solution. So what we do is we take the edge of our pencil and we shade that side of the line. Again, what that means is every single point on this side of the line, underneath this line, is a solution to y is less than 2x plus 1. So just to verify, let's pick another point. Let's pick the point 0, negative 2. Just to show that, again, every single point is a solution. So now x equals 0. So we do 2 times 0, which is 0, plus 1 is 1. So we remember the number 1. Our y value, again, is now negative 2. So we want to know, is negative 2 less than 1? Yes. Okay, and it should be, because this is in our solution region. Let's do one more. Let's pick the point 1, 1. So 1, 1 should be a solution because it's in this shaded region. So let's just show that it is. X equals 1. So we do 2 times 1 plus 1 is 3. Remember the number 3. Our y coordinate now is 1. So we want to know, is 1 less than 3? Of course. Okay, so every single point, no matter which point you pick, even all the fractions and decimals in between, every single point on this side of the line is a solution. And this is how we do it. We find our boundary line, or we graph our boundary line. When will y equal 2x plus 1? And we ask ourselves, on which side of this boundary line will y be less than 2x plus 1? Because again, y is less than 2x plus 1 on one side, and y is greater than 2x plus 1 on the other side. Okay, let's try another one. Again, this is something that practice makes perfect, so we're going to do a lot of examples here. So y is greater than or equal to negative 1/2 x plus 6. So I'd recommend just us working through this one together again, but if you want, you could always press pause, try something on your own, and then press play when you're ready to check. So the first thing we do is we always graph our boundary line. Okay, we want to know, where is this graph going to be split? So we want to graph, when will y equal, or where will y equal negative 1/2 x plus 6? So again, we're good at graphing lines at this point, and if we're not, then we have to go back and review those specific things. But our y-intercept is 6. So we start at 6. Our slope is negative 1/2. Okay, then we got to remember, what does negative 1/2 mean as a slope? Well, the negative means we go down. We go down 1 and over 2. And whenever we're graphing, we always go to the right. Down 1 over 2. Down 1 over 2. Okay, now is this going to be a solid line or a dashed line? Okay, solid, because we look at our inequality. This is or equals to, so we also care about when will y equal negative 1/2 x plus 6. And we draw our line neatly through these points. Okay, and this is a solid line. This is our boundary line. Again, this is when y equals negative 1/2 x plus 6. So we want to find on which side of the line will y be greater than negative 1/2 x plus 6. And until you make your own connections, until you make your own shortcuts, we're just going to stick with picking points and testing points. So I'm going to test the point 1, 2. I'm saying maybe this side of the line is where y is greater than negative 1/2 x plus 6. So I'm going to test the point 1, 2. Okay, now we're not afraid of fractions. We understand how to just work with them simply. So again, this is mental math, but I'll write it down so we can see the work that we're doing. We do negative 1/2 times our x value. Our x value is 1. So we do negative 1/2 times 1, which is negative 1/2, plus 6, which is 5.5. Okay, so negative 1/2 times 1 is negative 1/2. Negative 1/2 plus 6 is 5.5. Again, this should be mental math at this point. Our y value is 2, so we want to know, is 2 greater than our 5.5? Okay, no. I mean, it's not. Okay, so what does this mean? Well, this simply means that 1, 2 isn't a solution. So basically, we found the side where y is going to be less than negative 1/2 x plus 6, because 2 is less than 5.5. So this whole side is when y is less than 1/2 or negative 1/2 x plus 6. So it's safe to conclude that the other side of the line is when y is greater than negative 1/2 x plus 6. So this isn't a solution. So this is when y is less than negative 1/2 x plus 6. So again, it's safe to conclude that the other side of the line, above the line, is when y is greater than negative 1/2 x plus 6. But we're just going to verify. And we'll just verify with the 0.47. Negative 1/2 times 4 is negative 2. Negative 2 plus 6 is 4, is 7, which is our y value. Is 7 greater than negative 4? Sorry, greater than positive 4? Yes, of course, and that's what we expected. Okay, we found first that this side didn't work, so we can conclude that the other side should work. We found when y is less than negative 1/2 x plus 6, so we conclude that the other side of the line, and we verified that with the 0.47, is where y is greater than negative 1/2 x plus 6. As you can see, there's not a whole lot of work for these problems. All we're doing is using our boundary line, and we're good at graphing lines at this point, to figure out when will y equal negative 1/2 x plus 6. And then we want to figure out the side of the line where y is greater than that. Okay, so we tested a point. This point didn't work, which isn't a big deal. It just means this point isn't a solution. Okay, this isn't where y is greater than negative 1/2 x plus 6, so then we said, well, then it's got to be the other side of the line. Okay, then we just pick a point over there to verify, and we did. So this side of the line is when y is greater than negative 1/2 x plus 6. Okay, one more that we're going to do together, then you could try a bunch on your own. What if we see one like this? 3x minus y is greater than 4. Okay, well, at this point in the course, we do know how to graph this line. Now, we don't know how to do it right away, but we still need to graph our boundary line. Okay, we still need our boundary line, and that's where 3x minus y equals 4. Our boundary line is we want to know, when will this equal 4? Well, let's just graph this. In order to graph, we need to solve for y. This is something we know how to do, so we look at how do we solve for y? Well, what's done with our y's? What's with our y's that we don't want with our y's? Yeah, exactly, the 3x's. Well, how do we get rid of the 3x's? Well, we subtract 3x from both sides. We have negative y equals negative 3x plus 4. Okay, we kind of just flip it over. Positive on the left means negative on the right. And we are cautious to keep our negative y, because minus y becomes negative y. Okay, we're not happy yet. We don't have what y equals. We have what negative y equals. So, again, we saw examples like this before. This is where we just divide everything by negative 1. So we're left with y equals negative 3 divided by negative 1, which is positive 3. The sign just flips. 4 divided by negative 1 is negative 4. Again, the sign just flips. So this is our boundary line. Y equals 3x minus 4. Again, if we're given it in standard form, you simply have to graph it, and we graphed it by solving for y. And that shouldn't be intimidating at this point. So we graph our line 3x minus 4. Y-intercept is negative 4. Our slope is 3, so we go up 3 over 1, up 3 over 1. Now we ask ourselves, is this line going to be solid or dashed? We look back at the original inequality. Well, this is just greater than, so the line is going to be dashed here. Okay, again, this is the dashed line. Okay, the line is just dashed because we just have the greater than, not greater than or equal to. So, same process. We want to know which side of the line is 3x minus y going to be greater than 4. So, our process is, let's pick a point. Okay, I'm going to say maybe it's above this line. Maybe it's this side of the line where 3x minus y is greater than 4. So I'm going to pick the origin. Okay, maybe it's the point 0, 0. Maybe 0, 0 makes this true. Now what you need to do is you have to take note. You always have to substitute this back into the original inequality. Okay, not with any of the work we did for the boundary line. It has to go back in the original inequality. So you must test points with the original inequality. Okay, that's not a big deal. So we're just going to substitute 0 in for x and 0 in for y. So we want to know what is 3x minus y when x and y both equal 0. So 3 times 0 is 0, minus 0 is still 0. Again, this is mental math. We're just going to write it out so you can keep track of what we're thinking. 3 times 0 is 0, minus 0 is 0. Well, is 0 greater than 4? No, of course not. Again, what does that mean? That simply means the point 0, 0 is not a solution. Well, if this side isn't a solution, that leaves it safe to conclude that the other side is where 3x minus y is greater than 4. Again, if one side is where 3x minus y is less than 4, the other side is where 3x minus y is greater than 4. We found the side that's less, so it's safe to conclude that the other side is more. We're just going to verify. Let's verify with the point 3, negative 1. So 3 times 3 is 9, minus negative 1 is 10. Is 10 greater than 4? Of course, okay? Again, we do 3 times our x value. 3 times 3 is 9, minus negative 1. That is 10, and 10 is greater than 4. Again, what does that mean? That means 3, negative 1 is a solution. So every single point on this side, just like we thought, is a solution to the original inequality. So this is the side of the line that we shade. Again, that's how we graph linear inequalities. Okay, we find our boundary line, we graph our boundary line, then we test points on the other side, because the boundary line this is where 3x minus y equals 4. We want to find which side of the line is this expression 3x minus y greater than 4. We found that by testing our points and shading that whole side. Okay, press pause, try these two, and then press play when you're ready to just quickly go through your answer or check your answer. Okay, so we want to first graph our boundary line, x minus 2, so this is the line x minus 2. Okay, the y-intercept is negative 2, the slope is 1. This line is solid because it's or equals to. And after you test your points, you should have found that the top is where it's shaded. Okay, you would test a point up here, like the point 1, 1. 1 minus 2 is negative 1. The y value, which is also 1, 1 is greater than negative 1, so that's a solution. That's why this side is shaded in. Okay, this next example, y is less than 2/3 x plus 1. Y-intercept is 1, slope is 2/3, you go up 2 over 3. You just go in both directions. Dashed line, because it's not or equals to. And after you do the correct work with checking your points, you would shade the region underneath. Okay, just to show you that something works, let's pick the point 3, 1. 2/3 times 3 is 2, plus 1 is 3. Y is 1, so is 1 less than 3? Yes, of course, so we just verified our solution. Okay, last one. Press pause, try it, and press play when you're quickly ready to go over your answer. Okay, first thing we need to do is solve this for y to graph our boundary points. We have 2x or 10x plus 2y equals 0, so we get 2y equals negative 10x. So y equals negative 5x. Y-intercept is 0, slope is negative 5. This is the dashed line. Okay, and the side that you shade is over here. Okay, to verify, let's pick the point 0, negative 1. 10 times 0 is 0. 2 times negative 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 is, of course, less than 0, so that just verified our solution. Okay, so for more practice, refer to the textbook or the packet or some of the other online resources.